Hello, everyone. Signed number lines are how you'll need to use these a lot in AP Calculus, because we like to describe when a function is increasing and decreasing, or concave up and concave down. But before calculus, you'll see signed number lines with some sorts of inequalities. But the technique that is needed is to draw a signed number line and then to label it with the positives and negatives, and then to solve a problem. Now, I'm going to use my first example where you can just describe where a function is positive by factoring. And so we can factor out a x. And, you'll see trinomials with leading coefficients a lot in AP Calculus, but they're not the crazy difficult ones where you have to guess and check like 20 different things. For example, here, the binomials would have to be 3x and x. And then it's just a combination of 2 and 1. So I think we'd want to make the 3x times 2 is 6x, and this is x. So make this negative and that positive. And now you can do a signed number line by putting in the zeros. So we have 0, we have 1/3, and we have -2. Okay, so one key here is that all the factors, there aren't any double roots. I don't see any even exponents. In fact, there aren't any exponents at all. So all you really need to do is one test point, and then the sections are going to alternate every time. And if x is large, just larger than 1/3 here, but let's say 10, this would be positive, 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 so we know it's positive. And if none of the factors have any exponents at all, then it's going to, as you work backwards, it's going to alternate negative, positive, negative, positive. And so where is this function positive? From -2 to 0 and 0 to 1/3. Notice how we don't want to do a test point between 0 and 1/3 because, it's a little more difficult to plug in 2/3. So it is nice to know this little shortcut. Okay, let's do that one more time. Here you'd want to factor the top as 2x plus 3, 2x minus 3, and this has x on the bottom. Now, another requirement in AP Calculus is not to just do any number line. The number line should always reflect the domain, because domain becomes a bigger issue in AP Calc. So it's nice if your number line has a domain. And here x can't be 0. And then the two numbers are going to be 3/2 and -3/2. And if we do a test point, if x is large, positive, 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 it's positive, it's going to alternate every time. Even though there's an asymptote, it will still alternate. And so now we want to solve greater than or equal to 0. And notice we want this section here, but we'd want brackets around the -3/2, but not the 0, because there's an asymptote there, and that's one benefit of having a hole there. And then also from 3/2, nope, that would get brackets, 3/2 to infinity. So you can solve an inequality with the greater than or equal to. Okay, now then, some more difficult twists on that. One, I see we have even exponent. So this whole plus minus thing's not going to work if there's an even exponent there. Also, we have a domain issue of square root of x, and also at 2. So let's just focus in on the domain. I know x has to be greater than or equal to 0, so I'm going to start my number line at 0. And also I see that x cannot equal 2. So I'm really going to draw my number line first, just focusing on the domain. What other numbers are important? It looks like the 3 is important. We have the 2. Okay, now let's do a test point. Don't always assume that if x is large, you'll have a positive. If x is large, it's going to be positive, positive, negative. All right, and normally we go negative, positive, negative. What do you have to recognize? If you have an even exponent, a double root or a root of times 4, then it is not going to flip at the 3. So as I go backwards, it's not going to change, but it will change at the 2. So that shortcut is really necessary to be good at. to be accurate with these. All right, and now we want to solve this problem. We want when x is less than 0, so that's going to be from 2 to 3 and 3 to infinity. It does not have the or equal to part, so we do not want the 3 there. All right, ln has its own issues. First, you can't take ln of 0. You can't take ln of a negative. So not only is the number line going to start at 3, but there's going to be a hole here too, because you can't take ln of 3. All right, if we set the bottom equal to 0, and lots of times we just fly through these, we assume that it's going to be 6. You might think that your number line looks like that. But we also want to set the top equal to 0. We get this equation, ln of x minus 3 equals 0. If I raise both sides to the e, I end up with x minus 3 equals 1, and that means that x equals 4. So 4 is another root. All right, and so if x is large, the bottom is positive, ln of a big number is positive, it's going to be positive, it's going to flip at the negative, it will flip at the 4. And that's because what would ln of x minus 3, what would just that function look like? That would have an asymptote at 3 and a 0 at 4. It's going to look like that. So to the right it's positive, to the left it's negative. We have that, and to solve this inequality, we would go from 3 to 4 and 6 to infinity. All right, so here's some good practice problems down here. Good luck. The answer key will be up in the